When you picture space, you might think of vast emptiness, deadly radiation, and temperatures that would freeze or boil you alive. For all known life, even a few seconds of exposure to the vacuum of space would mean instant death. Organs ruptured, cells shredded, DNA bombarded by cosmic rays. But there is one animal that defies these rules, an organism so resilient it has rewritten our understanding of what it means to be alive. Meet the tardigrade, affectionately known as the water bear. In 2007, an experiment led by the European Space Agency and supported by NASA sent a payload of these microscopic creatures into orbit. The plan was audacious: expose tardigrades directly to open space. No protective suit, no special shielding, just the raw, merciless void. For 10 days, they drifted outside the ISS, subjected to the full brutality of the cosmos. Most scientists expected total annihilation. Instead, the tardigrades surprised everyone. Not only did many of them survive, but when they were brought back to Earth and rehydrated, they revived as if nothing had happened. Some went on to reproduce with their offspring, showing no ill effects. When the experiment was repeated, the outcome was the same. Twice, these creatures had stared into the abyss of space and survived. The secret of the ton state. How is such a feat even possible? The answer lies in one of the tardigrade's most remarkable abilities, cryptobiosis. When faced with extreme conditions, desiccation, freezing, radiation, or even space vacuum, the tardigrade withdraws its 8 stubby legs, loses almost all its body water, and curls up into a dry, inert ball called a ton. In this state, its metabolism slows to 0.01% of normal, essentially suspending its life processes. Inside the ton, tardigrades produce unique protective molecules. A special sugar called trehalose replaces water in their cells, preventing the formation of destructive ice crystals and stabilizing cell structures. Even more astonishing is the presence of unique proteins, such as DZUP, damage suppressor, which shield their DNA from radiation and oxidative stress. In the vacuum of space, where radiation would shred DNA and vacuum would boil away any moisture, these defenses keep the tardigrade's vital structures intact. When reintroduced to water, the tardigrade rehydrates, its metabolism reboots, and it resumes life, often just minutes after revival, as if waking from a deep sleep. Why tardigrades matter. The story of the tardigrade isn't just a scientific curiosity, it's a beacon of possibility. If we can understand and harness their survival mechanisms, the implications could be immense. Imagine preserving human organs for transplant without ice or chemicals, simply by drying them out and reviving them when needed. Or astronauts equipped with tardigrade-inspired shields, able to venture further into space, protected from deadly cosmic rays. Tardigrades have also sparked the imagination of those searching for life beyond Earth. If such resilience is possible here, could life exist in the harshest corners of our solar system, on Mars, Europa, or even beyond? The humble water bear suggests we should never underestimate the tenacity of life. More than a microscopic marvel. Tardigrades are everywhere, in moss, lichen, soil, and even the ocean depths. Despite their size, just half a millimeter long, they are among the most indestructible creatures ever discovered. They have survived boiling, freezing, crushing pressures, and the vacuum of space. And through it all, they persist, going about their microscopic lives, oblivious to the fact that they have become the champions of survival. So, next time you gaze up at the stars, remember, the toughest astronaut isn't a human, but a tiny, nearly invisible animal that's already been to space and come back home, completely unfazed. The tardigrade isn't just a survivor, it's a symbol of life's incredible ability to endure, adapt, and thrive in even the most impossible places.